we will discuss models of distributed systems. So, what is a model? A model is an abstraction of the relevant properties of a system. Abstraction means that some of the details of the system we discard as irrelevant and keep the properties that are relevant, those that we are interested in. So, why do we construct or learn a model? Because the world is complex. A model makes assumptions and simplification, but it does not make too strong assumptions or is not too simple, otherwise it becomes useless. We reason about realities in the model. This helps us tackle the complexity of the real world. So the model and its properties are expressed in precise mathematical symbols and relationship. This is an important property of a model because it helps us rigorously reason about the system and problems by only using the properties of the model. So, what can modeling do for us? It is useful when solving problems. For example, designing an algorithm. And when we are doing so, we are reasoning about the properties of the algorithm in the model and not in the real world. Because a model is precise, we can use it to predict behavior. For example, the cost of the algorithm in the number of messages being sent. We can also use the model when evaluating and verifying a solution, either by simulation or by formal methods. So in general, modeling is a very important skill. There are different types of model. Continuous models, often described by differential equations involving variables which take real continuous values. So typically, we define a phenomena as a function of time. So time is a continuous variable. Then we have discrete event models, often described by state transition systems, a system that evolves, moving from one state to another at discrete time steps. This course is a course about modeling distributed computing, and we use a discrete event model. The biggest challenge when modeling is to use the right level of abstraction. The model should be powerful enough to construct impossibility proofs. And what I mean by impossibility proof, that a statement about all possible algorithms in a system. So, for example, it should be possible in the model to prove that it is impossible to solve a certain problem. And that is a statement about all algorithms. Or state that no algorithm can solve a certain problem in model X if half or more processes may fail. That's also a statement about all algorithms. In any case, our model should be precise, so you can use it for these different proofs, but it should be concise. And it should be concise so that we can explain a class of distributed systems compactly. So what we are going to do now is to define a discrete model based on input-output automata for distributed systems.